Good morning, everybody. Thanks for joining us here on another edition of the Building Smart Energy Efficiency Essentials for Modern Homes series. As is typical, we're going to go ahead and give it just a couple moments for folks to start to arrive, and then we'll kick off the session in earnest. So just give us a minute here and we'll get going then. This is okay. All right. So we're going to go ahead and rock and roll here. Again, thank you so much for joining us once again. And excited to have some new folks here. We've got Victoria just chimed in to say hello from the Carrier HVAC, ductless, and VRF team. So thank you, Victoria, for joining us. And so continuing with our series, if you're new to the game here, we have been doing a just about every week webinar series sponsored by DTE and Consumers Energy on building smart energy efficiency essentials for modern homes. And the goal here is upping everybody's game, upping everybody's knowledge about how to apply higher performance building practices in the state of Michigan so that our homes that we're building are more comfortable, more durable, more resilient, and hopefully have better air quality and lower energy bills for consumers through following these best practices that we talk about week after week on this series. And so today we're going to continue our discussions about the Energy Star Homes program. And we're going to be specifically talking about HVAC systems in Energy Star. So again, we'll just do a little bit of a breakdown on what Energy Star is and what it isn't, as well as how you can participate in the program through DTE and Consumers Energy's residential new construction programs. And then we'll kind of take a deep dive into the specifics about Energy Star as it pertains to HVAC and air quality measures within the program. So it's not just about equipment. It's not just about what furnace you put in or what heat pump you put in. There's more that goes into Energy Star as it pertains to HVAC. And I'd say, if there's anything that really kind of stands out about the Energy Star program, it's the focus on the more specific details of implementation on heating, cooling, and ventilation equipment. So this is going to be a good session here. Again, I'm Chris McTaggart. I'm the president of Building Efficiency Resources. We are a national residential and multifamily energy efficiency quality assurance and training provider. We work with about 500 certified professionals that are involved in third-party verification and home energy ratings around the country, including many that live and work here in the state of Michigan. I myself live in the city of Detroit, was born and raised here, went to school here in college in the state, and then moved out of state for a few years to get my career started and decided to come back because I love my home, the Mitten State, the Great Lakes State, and I've spent a lot of time not just here in Detroit, but I've had the privilege to go to all the different far corners of the state, and I have a true, affinity for our landscape and the people of Michigan, and I have a passion for trying to educate people to implement better building practices here in the state of Michigan. Why? Because they make sense. They do help people have a better quality of life. And isn't that what we're all looking for? So again, if you've been here the last 2 weeks, you've already learned a fair amount about Energy Star, but we know that not everybody can make every single week. So just a brief, quickie overview. Energy Star for buildings, there's several different blends or flavors of the Energy Star program. I think most people think about Energy Star in the context of domestic appliances and consumer electronics. You know, my computer has a little Energy Star sticker on it. So I think that most people think about it in terms of those more consumable products that we see in big box stores. But the Energy Star label is so much more. The Energy Star program labels building materials like windows and insulation and HVAC equipment, but they also have whole building labeling programs. And so there are programs for commercial buildings. So if you go to a Target, for example, many of their buildings are Energy Star labeled buildings. There's also industrial plants can be labeled as Energy Stars. So you could go to some type of a warehouse type of situation or manufacturing, and that, you know, basically that building or process can be labeled as Energy Star. Those are beyond the scope of what this training is. We're focused on the application of Energy Star to single family homes, as well as to a lesser extent to multifamily and manufactured homes. These homes-based programs, they all have a similar feel to them. But again, the whole house gets labeled. So it's not just about what kind of appliances they put in or what kind of HVAC equipment, but it's a whole house construction, testing, verification, design, and labeling program that's promoted by the EPA. And the idea is that Energy Star homes are 10 to 20% more efficient than standard homes that might be built to a local energy code. So if we take a look at this continuum here, Michigan is on a version of Energy Star, which is the Energy Star version 3.1 program. Why? Well, because, nationally, the EPA sort of decided to up the entire country to version 3.1. But the intention why Michigan was on 3.1 is because we are on a version of the 2015 IECC. And if you paid attention in previous webinars, we're actually a little bit further behind in practicality when you look at some of the weakening amendments to our 2015 version of the code. From a performance basis, we actually perform a little bit closer to the 2009 IECC. But regardless, the point here is that Energy Star has created continual program modifications to deliver savings above energy codes over time. So, you know, the 2006, it doesn't really show this here, but there used to be version 2 of Energy Star. And so that was supposed to be, you know, 10%-ish better than the 2006 IECC. 2009, you get 10% better than that, you get Energy Star version 3. Again, we're at version 3.1. It's about 10% better than the 2012 to 2018 IECC versions, which were quite a bit similar to one another. If you were in Illinois, which is on the 2021 IECC, our Great Lakes state brother, they would be on Energy Star version 3.2. Why? Because Energy Star wants to deliver above code savings there as well. Many states are eyeing potentially moving to the 2024 IECC, at which point version 3.3 would become relevant. Okay, again, there are several flavors within this sort of family of homes programs. The single family homes program is what we're going to be spending most of our time focused on, although many of the same practices and principles are applied in the Energy Star multifamily new construction program, as well as the Next Gen program. We will be having a session that is specific on Next Gen here as part of this webinar series. So you can learn more then about Next Gen. We're focused primarily on single family homes. Why? Well, because the residential new construction programs from DTE and Consumers Energy do offer incentives to encourage people to participate in that program and to certify homes to that program standard. So it makes sense for us to focus there. Basically, we're looking at single family homes, detached two-family homes. So, again, we'll call it a duplex perhaps, or townhomes of, most configurations can fall under the single family homes program. It does get a little bit tricky if you have sort of like top bottom style units, then many times those are actually kicked over the into the multifamily new construction program. But get with your rater, and they can get with their provider if you need any interpretation on that. Again, the multifamily program is kind of everything that's not a single family house, in a duplex or a townhouse. And so we're not going to spend a lot of time on multifamily new construction, just because that's really a program that's really more focused on larger apartment buildings primarily, and that's just not necessarily what the scope of our presentations are. We're really kind of focused on low-rise residential as part of this series. So looking at the single family homes versions nationally, you'll see most places are on version 3.1. Again, the Energy Star program decided that continuous improvement was important. So even though not every single state is on a 2012 to 2018 IECC equivalency, the Energy Star program decided it was important to start to move the needle forward here. So Michigan, like most other states in the country, are required to comply with Energy Star version 3.1 at this point. Again, if you were to go to Illinois, they're close to implementing version 3.2. Whereas if you went to, say, Florida, they're already on version 3.2. There are certain locations like Hawaii, the Pacific Islands, the Caribbean, as well as California, that have their own regional based programs. But otherwise, by and large, at this point, most of the country is on version 3.1. However, if you choose to participate in the program and you want to earn the 45L tax credit, which is available for homes that are acquired prior to July 1st, 2026, then you have to up your game to version 3.2 or 3.3 of the program to earn that tax credit. So keep that in the back of your mind. You have to go all the way to version 3.2 or 3.3 if you want to earn that tax credit, basically. Next gen, we've teased it a little bit. Next gen is an electrification flavored version of Energy Star, and more or less it's about the same as version 3.2. So this gives you on this slide some sort of relative HERS score targets that you should expect for participation. Yeah, this helps you kind of look at that. Again, if you're just trying to earn Energy Star and label a home as being certified Energy Star in the state of Michigan, you just have to be version 3.1. And this gives you an idea of the incentives that would be available to you. So through Consumers Energy, if you are an Energy Star home, those incentives can range from a few $100s all the way up to a few $1,000s, depending on how efficient the building is, as well as what fuel source Consumers is providing. So let's just say, for example, that Consumers is providing only natural gas, and the home scores a 52 on the index and is labeled as Energy Star. Well, we would be at this 46 to 55 tier, and it is Energy Star, and so you would be eligible for up to $1,400 from Consumers Energy. And if DTE were the electric provider, then you would be eligible for incentives through DTE as well. There is a limited pilot that Consumers had for 2025. Enrollment is now closed and homes have to be completed by the end of the year, but there were some bonus incentives available for Consumers Energy for Energy Star Next Gen. DOE zero energy rating homes as well as passive house. So hopefully you might have been able to get in the door for that. Again, the 45L tax credit is set to sunset at the end of June next year. But if you're in the process of building and you think you'll be complete and the home will be either sold or rented by that time, then you'll be eligible for potentially achieving a tax credit of $2,500 for Energy Star. Again, you have to hit version 3.2 or 3.3. Or you could up your game and get all the way to $5,000. Let's take a look here at DTE's incentive chart. So DTE, similar threshold of compliance to get in the door. They're at a HERS 60 versus Consumers is at a HERS 59 in order to get started with Energy Star. But again, let's say that same home that was in Consumers territory, Consumers provided the natural gas for a $1,400 rebate. So for DTE, they're providing the electric, and it is an Energy Star home. And we have at least a 60 on the HERS index, so we would be eligible for an incentive of up to $1,800. The way that DTE's incentive tiers work is it's a little bit more pay for performance as well as some prescriptive incentive tiers. So that $1,800 is a ceiling, not a floor or a guarantee. But regardless, if you were to build an Energy Star home in DTE and Consumers mixed territory, you would be eligible for somewhere there in the $3,000 type of area for incentives, more than likely. So that's exciting. That's a nice little cherry on top, and especially if you add in the $2,500 through the federal government for the 45L. Hey, we're looking at over $5,000 of incentives. That's nothing to sneeze at. Okay, so having gone over the basics of the program, let's go ahead and switch gears into the specifics of HVAC equipment in Energy Star. And, just sneak peek, it's not about the equipment being labeled. It's an important thing to note. Energy Star as a program, the single family homes program, does not actually require Energy Star labeled HVAC equipment. There is an exception if you use bath ventilation as your whole house ventilation strategy. The bath fan has to be Energy Star. But aside from that, our heating system, our cooling system, our water heating system, our ventilation system, none of these other things actually have to be Energy Star in order to participate in the program. Why? Well, because it's a whole house labeling program. It's focused on the whole building and how it performs, not individual subcomponents. So here we are. We're in the areas that we're focusing on as the key elements of Energy Star. What is the value proposition of Energy Star homes? Well, it starts with code and then it adds in some key features. Properly sized and installed HVAC systems is a key feature for comfort. Having bedrooms be properly balanced so that the comfort is optimized even if we have our doors shut is another key principle of Energy Star. Having a whole house ventilation system as well as local mechanical exhaust systems, also key attributes. Having reasonably good filtration on our HVAC system in order to promote better air quality, but also keep our equipment in tip-top shape is another key attribute of Energy Star. And then finally, we want to make sure that we're putting smart combustion equipment in homes. If we're doing combustion, we don't want to put in equipment that might be risky long-term from an air quality standpoint. So there is a combustion safety element of the program as well. So again, these are the key features of Energy Star that are related to HVAC that we will be discussing today. So first and foremost, when we talk about how to participate in Energy Star from the lens of an HVAC perspective, it is important to note that when Energy Star version 3 came to market, it required that the installing HVAC contractor, the contractor who actually installed the heating and cooling equipment, had to be credentialed through a Energy Star approved training and quality assurance organization called an HQIDO organization. The two HQIDO organizations that are recognized by the EPA are ACCA as well as Advanced Energy. So historically, up until about a few years ago, that was the only way to certify Energy Star, was to have a credentialed contractor participating in the program. However, with the launch of the ResNet ACCA HVAC grading standard, the 310 standard, now raters can actually go and perform those testing and verification steps for verifying that HVAC equipment was properly installed, which then allows for the HVAC contractor to not be credentialed. So I'll say increasingly so, there has been a movement here recently for raters to earn this credential to start taking on HVAC grading on behalf of their builders. Still not a bad idea for the HVAC contractor themselves to take training and or become credentialed, but perhaps it makes the process a little bit more straightforward when the rater is able to do some of this extra testing and verification. The types of testing and verification we're talking about are testing the total system airflow on the HVAC system. So the air handler itself, when you do a design for HVAC systems, typically air handlers can run at several different speeds, and their airflow can potentially be sensitive to things like restrictions or duct sizing. Testing the airflow to make sure that we're actually getting the proper amount of airflow as per the design is something that the rater might do as part of that HVAC grading process. Concomitant with that would be testing the blower fan watt draw. Again, certain blower fans are sensitive to back pressure, and they may increase their electrical consumption if met with significant resistance. And so the rater is able to test the watt draw of air handler systems. And then finally, we have refrigerant charge. Typically, raters are not actually doing physical measurement of refrigerant charge, because generally speaking, raters are not credentialed or licensed to perform direct physical measurements of refrigerant, but there is an indirect, non-destructive method to be able to perform a refrigerant assessment that's based off of temperature considerations of the system. Or alternatively, the rater can get a photographic documentation of a weigh-in method by the installing contractor to document that process of refrigerant charge verification. Okay, so that kind of gives you the broad overview of the options for getting in the door. You could either work with your rater, who is an HVAC grading, trained and certified rater, or you could have a credentialed contractor through an HQIDO program, who is the installing contractor. The first big process for going with the Energy Star HVAC process is to document the HVAC design. So when we talk about HVAC design, we're talking about the process of conducting appropriate energy load calculations to predict what the heating and cooling loads are going to be for each specific home in its specific location, and then to select a appropriate sized unit for that home. And then finally, to design the distribution system to ensure that we have heating and cooling that are going to all the appropriate spaces of the home. So this is what we more broadly refer to as HVAC design. So this is the key first step for Energy Star homes. You have to have an appropriate HVAC design in order to move forward with Energy Star. So that could be performed by the installing contractor. It could be performed by an equipment vendor or supply house. It could be performed by, an architect or engineer, or it could even be performed by the energy rater. Oftentimes, energy raters will offer HVAC design services as a value-added service on behalf of builders. Whomever creates and submits the design, HVAC design, the rater then has to take that and perform a limited scope review using the Energy Star design checklist, design review checklist, which ensures that there's a logic check on some of the key variables to make sure that the design appears to be appropriate for the home. When you do track A, which is the HVAC grading process, then really that process is pared down because a lot of the HVAC design review is being done through a separate ResNet design review scope. But it's very similar type of approach ultimately. This is an example of that ResNet 310 HVAC design report and therefore the review. This gives you an example of what may be looked at for HVAC grading, and essentially, the same terms and conditions apply for Energy Star. This is a supplement, so something that might be spit out as a supplement if you're following that HVAC grading process. That helps to basically provide any additional context that's required for the Energy Star program. So many checklists, and get with your rater on how to navigate those, because the devil's in the details in terms of documenting the process. Okay, so track A, again, this is the HVAC grading process. There's 5 tasks as part of the HVAC grading standard. And so it all begins with design review. So again, whomever, whether it's the installing contractor, a third-party architect or engineer, a supply house, or the energy rater themselves, whoever performed the HVAC design, the rater then has to do a design review to ensure that it's appropriate for the house in question. Does it match the house? I'll just say, you may think this is kind of like a no-brainer thing. Shouldn't this happen on every single home? Well, technically, yes, it should. Homes built to the Michigan 2015 code are required to have equipment that is designed by a load calculation and system selection through ACA Manual J and S. So yeah, this shouldn't be a big deal, but let's just say the implementation of that is not necessarily uniform. So for that reason, Energy Star does have this more specific design and review process to ensure that it's actually being done. So we start with the design review and then move to assuming that that is correct, the equipment was designed appropriately for the home. Then the rater is able to perform total duct leakage testing, and sort of a minimum level of duct tightness is required, followed by blower fan airflow testing, basically to make sure that we're moving enough air from our HVAC system that will help to heat and cool people. And then we'll do a blower fan watt draw. It's important to note that's actually an optional test for Energy Star. You don't have to do a blower fan watt draw if the rater either doesn't have the appropriate equipment or they're not licensed to do that type of a test. But I personally think it adds a lot of value. And then finally, a refrigerant charge review, either the non-invasive method or the weigh-in method would be allowed. All right, so design review. Again, there is a form to fill out from ResNet that the rater will fill out to basically document that design review it took place and that the equipment that was chosen was proper for the home and that there was a proper duct design performed. Then we move to total duct leakage testing. And basically, we have to meet the total duct leakage limits as specified by Energy Star, which are at final. We'll just focus on final. If you have less than 3 returns, then 8% total duct leakage is our limit. If you have 3 or more returns, which is oftentimes typical for Michigan, where a lot of dedicated returns are utilized, 12% leakage per floor area is permitted. It is possible to test it rough in. I'll say it's a little bit more tricky for Energy Star because you have to have the full air handler and all the ducts installed. If you're using any building cavities as ducts, which is often the case in Michigan for returns, that full system has to be all the way in. So you can't just test it rough with a partial system in. So it's for that reason I don't usually see rough-in testing used here in the state of Michigan for compliance, but you certainly could. More typical would be to see it at final. And again, it depends on how many returns you have in the house, whether your threshold is 8% per floor area or potentially up to 12% per floor area. How do you may think, well, those limits don't seem that stringent. Isn't every home in Michigan achieving this anyways? Isn't duct sealing required by the code? Well, duct sealing is required by the code. You have to seal ducts. However, let's just say there's good enough for a visual verification for a code official level of duct sealing, and then there is a more significant level of duct sealing that may be necessary in order to really achieve these rates. Ductwork is a fabricated product that has a lot of seams in it, and it can also be sensitive to getting cut or spliced, where the tightness is reduced over time. And so, there's a lot more that goes into proper duct sealing. Obviously sealing all the basic seams of the system are required, but also sealing the duct boots themselves. So the inside of boots and fittings should be sealed. The connections between the fittings or seams of boots need to be taken into consideration. Then finally, you have to seal the boot to drywall or boot to finish floor connection, because that's a place where you can have a lot of leakage as well. Someone mentioned here, Ryan, not 4, 8, or 12% leakage verbally stated by Chris, but rather 4, 8, or 12 CFM 25, which is much lower. Yeah, I want to go back and just clarify this just to make sure we're clear on this. When we talk about leakage, we're talking about leakage per floor area. So when I say like 12%, the reason why I say that is it's 12 CFM tested at 25 pascals per 100 square feet. So in other words, if you divided 12 divided by 100, that would give you 0.12 or 12%. So you could either say it the long way, so 12 CFM 25 per 100 square feet of floor area served, or you could just say 12% leakage. I'd say colloquially within the rater community, we tend to speak more in the narrative of percent of floor area rather than saying the entire mouthful of leakage per 100 square feet of condition floor area served, it's just more of a mouthful. So it's a lot easier to say 12% leakage, 8% leakage, 4% leakage, etc. But they mean the same thing ultimately. Thank goodness we don't have to hit literally 12 CFM for the whole house, because no house would ever be an Energy Star home, because getting to those exquisite levels of almost zero leakage are practically impossible. Okay, so moving on. Again, the boot to finish surface connection, very critical. So we see two photos here. The one on the left shows a pretty typical install if you were to remove a grill and to take a look at how the boot, which is the rectangular typically, fitting that then connects to the finished surface, whether it's a wall or a ceiling or a floor. The boot to drywall connection needs to be nice and clean and tight. Why? Because otherwise, when we have that grill face over the boot, then air is slamming against that grill with significant velocity, and some of it's going to end up bouncing back and going back into the wall or the ceiling cavity. And especially if you have any ducts that are outside of conditioned space, that's going to exacerbate that issue and cause there to be leakage to outside. So you can see a savvy rater probably ran their test and realized they were not passing, chose to pull off the register grill face and saw that there were significant gaps around a good portion of those boot connections. So you actually do have to seal those connections. This is the number one failure within Energy Star, not sealing boots to the finished surface. So don't forget about it. If you're working with a new builder, a new HVAC contractor, you really have to drill home the importance of this. Blower fan airflow, we're looking for it to be plus or minus 15% of the design flow. There's a lot of different ways to measure the blower fan airflow, but using a flow grid system created by the Energy Conservatory is probably one of the more direct ways of doing so, but there are several other methods. So for the purpose of Energy Star, we can either be grade 1 or grade 2. So you can actually have a 25% deviation and still be acceptable for Energy Star, but certainly you get more credit in the energy modeling if you are a grade 1. So, the way this works is you go with the higher of the airflow rates. So in this instance, it's the cooling airflow rate. But if we take a look here on the right, a test was performed by a rater, and we came out with 1142 CFM. And so that is, within, that's, 5% less than the design value. So we're still grade 1. Again, we could be all the way down to 25% less. So, potentially a more significant variation could be permitted. Obviously, we would prefer not to have a big variation, but 25% of 1200 gives us 300. So we could be all the way down to about 900 CFM and technically still pass. Obviously, we're happy to have something that performs better. Blower fan watt draw. Again, there's a few different ways to do it. My colleague Dylan Tyndall is illustrating in an image below that you don't actually need to use any tools. Sometimes if you have a house with a smart meter, you can just go ahead and turn everything else off in the house and just go take a look at the meter, and it'll tell you in real time how much energy is being consumed. And otherwise, if you need to do a direct measurement using a watt adjusted clamp meter, one that accounts for a power factor measurement, will help us give the specific level that is necessary for the test. And then finally, refrigerant charge. So my colleague Zach Mullins from BER is illustrating using a pipe clamp thermometer. which can tell us the temperature on the refrigerant lines, and that is one of the subcomponent values for the non-destructive testing method that raters oftentimes apply for testing refrigerant charge verification. And so, again, this non-invasive method allows for testing to be performed without an actual physical measurement of the refrigerant. It's based off of temperature conditions, both indoors and out, as well as measurement of the refrigerant pipes. So there is a process and some math that goes into it, but it at least allows for a non-destructive method of testing. Okay, so two methods again. So there's an invasive method as well, which is performed generally speaking by the installing contractor. This actually requires them to weigh in the refrigerant. This should be done by every contractor, most likely. Obviously, some equipment comes pre-charged, but it comes pre-charged for a certain line set length. That's not necessarily always the case for a home. There can be extra value to vacuuming down our refrigerant lines in order to remove any impurities from the system, and then going ahead and adding in the specific amount of refrigerant needed for the home. So again, most raters are not competent to perform that test. And as a result, this is something that is allowed to be documented using photos and data points to be then provided to the rater to document a refrigerant charge. So these are, the different methods that are allowed for documenting HVAC grading, which is a Track A option for HVAC installation verification for Energy Star. So there is an exemption on refrigerant charge. If the non-invasive method can't be used at final due to equipment type or outdoor temperature. So when we say equipment type, so variable refrigerant flow equipment, so like a lot of modern heat pump systems, you cannot use the non-invasive method for verification of refrigerant charge. So if you have one of those systems, say you have a inverter heat pump that's installed, the rater cannot use the non-invasive method. And so if you can't use that non-invasive method at final, or maybe you've got standard equipment, but the outdoor conditions are just not right. Let's say you're testing a home in Michigan in wintertime and it just has a standard air conditioner. Well, we're not going to be able to test refrigerant because you can't turn the air conditioner on in the dead of winter. So the home may be certified with a default grade 3 refrigerant charge. However, you can still use the weigh-in method in order to pursue a grade 1 designation if you want to get additional points. So the other value of the HVAC grading process, regardless of whether or not the installing contractor has to be credentialed or not, the other big value is that builders can get additional points through pursuing HVAC grading. I will say particularly for cold climate heat pumps, this can be very significant. Homes can achieve 5 or more HERS index points through getting a grade 1 installation. So it is worth it to builders to work with a rater that is qualified to perform HVAC grading, just insofar as it can really help the process and to get the builder some extra credit. Okay, so Dutch quality installation. So going back to the methods of qualifying a home, again, you have this Track A method, the rater does HVAC grading, or you have Track B, which is the installing contractor is credentialed by an HQITA organization. Regardless of which track you follow, the program has certain mandatory requirements as it pertains to HVAC systems. Installing ducts without kinks, sharp bends, compressions, or excessive coils is one of those requirements. I'll say it's a lot harder to screw this up with sheet metal ductwork. Michigan is not a huge flex duct market, but certainly it is used by some contractors. And so basically, especially with flex, you can't just sort of wing it and, well, it bends in all different types of crazy directions. So if it's able to, then I'm fine to do it that way. No, that's not correct. We want straight ductwork. We want non-compressed ductwork. We want ductwork to be installed where it's not tied into a knot or crushed by a framing member or a plumbing pipe or something like that. So, basically ductwork has to be installed without excessive degradation to its ability to deliver airflow. So other requirements, irrespective of track, is that bedrooms have to be pressure balanced to plus or minus 3 pascals with relation to the main body of the house. For those of y'all who don't really understand what this means, is a pascal is a unit of pressure measurement, and 3 pascals is it's a pretty small number. But the goal is that, in homes, people typically have bedroom doors closed at nighttime. Why? Well, because people want privacy at night. Because of that, if the home does not have a balanced return and supply in each one of those bedrooms, then when you close that door, then any stagnant air is not able to make its way back to a return so it can be reconditioned. And then the bedroom itself can actually act as a form of pressure resistance on the system when we're, calculating our total system airflow. So for that reason, bedrooms have to have some method of pressure relief so that the supply air, because pretty much all bedrooms are going to have supply air, the supply air has a way to make its way back to a return. That can be done through either a dedicated return in bedrooms that's balanced with the supply air coming in, or transfer grills, jumper ducts, or door undercuts. It says door undercuts aren't enough alone. That's not necessarily true. It's just oftentimes to achieve the level of significant pressure relief necessary. Oftentimes with a door undercut, it might cause there to be a privacy related issue. When people have their bedrooms doors closed, they probably want to have sound privacy. And so, otherwise, if we end up with, 1-2 inches of clearance at the bottom of the door, kind of looks weird. For one, it's not exactly aesthetically proper, and it doesn't really give people enough privacy. So raters are required to test the pressure in each bedroom to make sure that it is balanced with the main body of the home, plus or minus 3 pascals. There is an allowance for up to 5 pascals if a room has over 150 CFM of delivery into that room. We need at least modest duct insulation. So if you have ducts in unconditioned spaces, they have to be at least R6. So here we see insulation that is R8 in an attic. That works because it's at least an R6. What we wouldn't be okay with is if we go back a couple slides and we saw R4.2 up here in the top right-hand side. That would not work if that was a heating or cooling duct that was in an unconditioned space. That would not be sufficient. We would need to have at least R6. Okay, so moving away from heating and cooling systems to mechanical ventilation. This is one of the other, I'd say, like big value propositions of Energy Star. You could say, well, aren't homes by code required to have mechanical ventilation? And they are, but I'll say getting the specifics of that, especially in the state of Michigan, I found not everybody quite understands how to implement it properly. So mechanical ventilation systems by Energy Star have to be set to run automatically without the occupant intervening. And they're going to be either continuous or intermittent. And so, oftentimes in Michigan, we oftentimes see a fresh air duct coming into the return side of a plenum of a heating and cooling system. And that it just basically relies on whenever that heating and cooling system runs, then we're getting fresh air in the house. Well, the problem with that is that, like, take today, we have a very moderate day here in Michigan, temperature wise. I'm neither heating nor cooling my house. And so my air handler is not running. So I don't have any mechanical ventilation going on right now, and that's probably leading to me having more stagnant air inside my home. So the idea behind the mechanical ventilation requirements for Energy Star is that it's either continuous or it's intermittent, but it's on some type of program schedule. And you can't just use a standard bath fan or standard fresh air intake, and that's good enough. It has to be on some type of timer system or running continuously. How much ventilation air is allowed? You can use either the ASHRAE 2010 standard 62.2 2010, or you can go to a even more significant version of ASHRAE that maybe has a slightly higher ventilation rate. But the bare minimum would be 1% of floor area plus 7.5 CFM per person, and people are factored in as bedrooms plus one. So in this 1,800 square foot 3-bedroom home, you'd say 7.5 CFM times 4 people, because it's 3 bedrooms plus one. That would give us 30 CFM for the people, and then 1% of floor area gives us 48 CFM total. That would be continuous. That would mean that you'd either have one fan running continuously at 48 CFM, or you would have one that is set up to run at a higher rate, but on a reduced runtime schedule. If you're going to use exhaust-only ventilation, then you have to have them set up as Energy Star bath fans. Exhaust-only ventilation, it's pretty economical. It's easy to get right, meaning it's easy to set it up right. The challenge is that you don't know where the air is coming from. So, it can be coming from gaps and cracks in our building envelope adjacent to attics, crawl spaces, etc. And it can be noisy if it's not done well, but obviously if you choose an Energy Star bath fan, not only are they energy efficient, but they're also quiet. You can use a supply-based system, or AKA an air cycler. These will take that fresh air duct tied into the return side of the air handler, and then basically set it to a schedule that will ensure that it meets the ventilation needs for the program. The benefit there is that it's relatively economical. It's moderate in terms of complexity. It's not very efficient, though, because we're using our air handler to move around small amounts of air. And so it tends to hurt the HERS score, as well as it means that consumers are paying for their air handler to run. So the consumer actually has to pay for it. And it's hard to test the airflow and get it right. You're relying on negative static pressure to be able to bring in a specific amount of air. And you'd be surprised at how oftentimes I've seen very little airflow coming in out of these systems. So it's not predictable. You could get a supply only fan, so like a actual inline fan that's more dedicated. They're pretty efficient. They're low complex. They're a little bit extra money, but not that much. Depending on the model they use, it may or may not have the ability for a rater to test it easily. But honestly, I would consider this as another option. I'd say the other con is that in certain temperature conditions, you may be blowing in either very cold air or very hot and humid air. And so the feeling of that can be more palpable potentially for the customer. The solution to that is to put in a balanced heat recovery or energy recovery ventilation system. The benefit of it is that it recovers some of the heat from our house, so that if it's really cold outside, we're pre-tempering that air so it doesn't feel so uncomfortable. These are also very energy efficient because they're capturing that heat flow, and there can be some very good ones that are relatively low electrical energy use. So oftentimes pretty easy to test by the rater. They're an expense, they're not free for builders, but boy, these are really the Cadillac solution for ventilation. So for raters to verify it, basically our ventilation has to be plus or minus 15 CFM in order for it to be compliant. So plus or minus, 15% rather, in order to be compliant with that ventilation airflow. Other things, so you have to label the system controls, and there has to be an override. And why is that? Well, imagine you're on a day where it's really foul air. We get one of those Canadian wildfire smoke days. You want people to be able to turn it off if it would really be better ultimately. So again, if you're going to use exhaust only and you're going to use Energy Star bath fans, then you have to be Energy Star bath fans. There's also a zone requirement for bath fans. They have to be less than 3 zones if they're intermittent, and less than 1 zone if continuous. But if you have a remote mounted fan doing exhaust only, like in an attic or something like that, then it's exempt from that sound requirement. Fresh air inlets, so if you're doing either supply ventilation or balanced ventilation, you have to have that inlet coming in at least 2 feet above grade or above a roof deck, and it has to pull directly from outside, not a compromised space like a crawl space or an attic. It has to be 10 feet away from known contamination sources like exhausts or combustion air, things like that. And it has to be at least 3 feet from things like dryer exhausts. So, if you're going to use either supply fresh air or balance with fresh air intake, there has to be some more thoughtfulness that goes into where you're placing these inlets. They also need to have rodent screens so as to make sure that they don't get fouled or allow vermin to make its way into the home. Local mechanical exhaust is kind of the pair with whole house mechanical ventilation. So kitchens and bathrooms need to have specific air volume. Kitchens need to be ducted to outside. You can't just have a recirculating hood. That doesn't work. You have to actually send the fresh air directly to outdoors. And depending on whether or not it's continuous or recommended, there is a zone requirement. These rates have to be tested. And these are unlike our whole house ventilation rates, which allow for a little bit of flexibility. These don't have quite as much flexibility. Bathrooms need to move at least 50 CFM if intermittent, so basically switch operated, or 20 CFM if continuous. Kitchens need to have 100 CFM intermittent, so again switch operated. But then if it's continuous, or if you're using a remote mounted fan, that rate could be potentially higher, and it's based off the volume of the kitchen. So a little bit more complex and specific, but regardless, it has to be tested. System filtration. So our heating and cooling systems need to have at least MERV 6 filters. These are better quality filters, basically, that can help to ensure that ultimately the system is being protected, our air handler is being protected from dust and debris coming in that might foul the blower motor over time, but it also helps to control some degree of dust and allergens in the home for the occupant. So this is something we see people maybe have a construction grade filter in during construction, and then they forget to change it out with a MERV 6. Definitely got to make sure that it happens for the rater to inspect at final. That filter slot needs to be gasketed or otherwise sealed. You can't just have it wide open to the basement as what we see over here on the right-hand side. This is a pretty typical thing where we see that 1-inch filter slot that's just wide open to the basement. That doesn't work for Energy Star. You have to have some type of gasket or covering. One of those magnetic covers would be acceptable as a minimum compliance measure. But obviously, if you had a 4 or a 5-inch filter, media cabinet, I think really more the Cadillac solution, because those are nice and gasketed and will ensure better filtration. Last but not least, in Energy Star homes, you have to make sure that any combustion equipment furnaces, boilers, or water heaters are either mechanically drafted or direct vented. What does that mean? Well, it means that either we have sealed combustion equipment like this furnace over here on the right-hand side. It brings in its combustion air from outdoors and it shoots the exhaust gases all the way to outdoors. You have a power vented water heater over on the left-hand side. Here in the center, we've got a standard atmospheric water heater. That doesn't work. That is neither mechanically drafted nor direct vented. And so for our climate, that is not going to work. You cannot have unvented or just atmospherically vented equipment. Obviously, all electric homes naturally meet this equipment because they don't have any combustion. So that's a pro for an all electric home. Fireplaces have to be mechanically drafted or direct vented as well. So we can't just have sort of natural atmospheric vented equipment in Energy Star homes. Can't have wall-mounted furnaces or fireplaces that are gas that just leach their combustion byproducts inside the home. That's not going to work. That is a risk. Okay, so we ended exactly on time. Powered through this one. Thank you all. No hiccups this time. Last week we had a little bit of a video issue at the very end of the presentation. My apologies for that. Regardless, we will see you next week for a presentation on Energy Star Next Gen homes. Look forward to seeing you then. Have a good week.